Writing exponential functions. First of all, what is an exponential function? Let's go ahead and write the outline. Y equals P A T. P, that does not look like a P. P, maybe. P is the initial condition. A is the growth or decay factor. And then T is the exponent, but it's also the x value. And here's the hint. Typically, exponential functions deal with population. Bacteria growth. The key word with exponential is rapid. And the reason that I say rapid is the main reason thing that you need to associate with these problems. Exponential functions go from little growth or little decay, and then they just take off growing just immediate. It goes from a little change to a lot of change. And the graph looks like this. An exponential graph looks like this. I'll fix this ladle. This is what an exponential graph looks like. You have, let me do it in red so you can see the point better. You start having very little change, very little, and then it just starts going up. It's more curvy, but that is basically what it is. Okay, so let's do an example. a country has a population of 7 million. That is growing at a rate of 1.75 per year. Note, growth rate less than 1, decay. Greater than 1, growth. To be on the safe side, let me write that out. Smaller, larger than 1. If it's smaller, it's decay. If it's larger, it's growth. Okay. Write a function to describe my computer's laggy. To describe there we go, this growth as a function of yields. So P of t equals the initial condition $7,000,000 times the growth rate. Oh, 1.75%. So basically, that's not the growth rate, that is the growth factor. How to get the growth rate is move the decimal place 2 to the right, so it'd be 1.075. Yep. That's right. And then T. This isn't right. P equals population in millions remandel. If you would have just put P of t equals 7 times 1.0175 to the t power, that'd be wrong. You have to tell me what P is, and you gotta tell me what T is, and the measurements. See, P equals population. Population could be in thousands, millions, billions, trillions, zillions. And time could be in seconds, minutes, hours, days, weeks, months, centuries, decades, millennials. You don't know, so you have to specify. And T equals time in yields. So while we have this uphill, and while we're on this subject of exponential functions, let's go over some more questions that you might get asked. Okay, so what's the population after 10 years? Let me make sure this is recording again. Okay. So basically what you do is you rewrite this according to the yields. P of 10, because it's 10 yields and it matches what T is supposed to be. Now if it said 10 months, we'd have to divide 10 by 12 to get that equivalent to a yield. So P of 10 equals 7 times 1.0175. Keep in mind that P of 10 just means that T equals 10. And put that up there. So from here, it's calculatable. And what you should get when you type it into the calculator is 8.326 million. And in the actual question, it'll tell you round to so many decimal places. This is 3 decimal places. If it wanted you to round to 2, 8.33 million. Generally, it will either be rounded 2 or 3 decimal places. Sometimes they'll ask you to round to the nearest whole number. And whenever you solve an equation like this, or whenever you have a problem like this, don't put 8.33 and exclude million. Always put million, because it's a growth equation. It's not a decay. There wouldn't be 8.33 people on the country, or in the country, I mean. There wouldn't be 8.33 people in the country, especially if it's growth. So always put your units. So here's another note. Always specify units. Thanks for watching. Don't forget to like and subscribe. Have a request for a topic? Comment the topic on this video. This slideshow is made with Microsoft PowerPoint.